Okay, class, right now we're looking at the chambers of the eye, the segments of the eye, the formation of the aqueous humor. Okay, we have chambers in the eye. We have what we call an anterior segment and posterior segment. Here's the posterior segment here behind the lens here. In that segment is something called vitreous humor. It's a jelly-like fluid, jelly-like, that helps maintain the shape of the eyeball. In the front here, the anterior segment, we have something we'll call the aqueous humor. It's more of a watery type fluid. Okay. So the posterior segment, which is back here, contains the vitreous humor, and it's very clear. It's jelly-like. It's very clear. It transmits light, supports the posterior surface of the lens, which is this, holds the neural layer of the retina firmly against the pigmented layer. Remember, we talked about retinal detachment. Contributes to intraocular pressure, that has to do with maintaining the proper pressure in there, glaucoma, things of this nature. And it forms during the embryonic period, and it lasts for a lifetime. It does not turn over. It does not turn over. The anterior segment, though, go back, I apologize. The anterior segment is composed of two chambers. An anterior chamber between the cornea, right here, and the iris, and a posterior chamber between the iris and the lens. And that's all in this anterior segment here. Okay. The anterior segment contains this fluid called the aqueous humor. It's a plasma-like fluid continuously formed by the capillaries of the ciliary process. Okay, so now let me go here. Now that we're at that part. Okay, let me blow this up a little bit. So the ciliary process, which is behind the ciliary body, produces this fluid, this aqueous, which is an ultrafiltrate of the blood, like the plasma. This fluid goes up right here, and remember, that's that posterior chamber of the anterior segment, floats around and then comes in and is drained. So it's a constant flow. You should put as much out as you bring back in. And it goes into the sclerovenous sinus, which many people will call the canal of Slim, this ophthalmologist. So it's a constant. If it's too much fluid going out, not enough coming back in, then that would be the glaucoma. Okay. This fluid, because remember the cornea is avascular, so how does it get its nutrients for these cells, these squamous cells? It would be located in this fluid here to provide nutrients and gases and so forth. So it drains venous sclerosinus, canal of Slim at the sclerocorneal junction, and supplies nutrients and oxygen mainly to the lens and cornea, but also the retina, and it removes waste. So it's a constant. So when we get into things like glaucoma, there are two types of glaucoma. One is what we call the open angle glaucoma and the closed angle. The open angle glaucoma is where that the fluid is produced, goes up, but there's something is blocking, and this is the most common, the canal of Slim. So the fluid builds up and you get an increase in intraocular pressure, which should be around 16 millimeters mercury pressure. And this pressure could push on the back and destroy the optic nerve and so forth. Then a closed angle glaucoma is one in which this iris here is stuck to the cornea, so you can't come back in here. That's a closed angle. So we have an open angle and closed angle glaucoma. Okay. All right. So that's what we call the aqueous humor. Let me go a little further down. And again, here's that here. Okay. So now we go to the lens. Come here. Here would be the lens. Go down a little bit. I'm sorry. Here would be the lens. You see these cuboidal cells here that's constantly turning over. Now this would be where light is coming in from the front. And then underneath that would be these fibers here that look like onion rings here. And so you have a constant turnover here that you have in the lens. By convex, transparent, flexible, and avascular, changes shape to precisely focus light on the retina. Lens epithelium, that's the anterior. Lens fibers at the back here. Lens fibers filled with transparent protein called crystallins. Lens become more dense, convex with age. And so some will call it presbyopia. Presbyopia. And then cataracts are where it becomes an opacity. It could be aging, could be diabetes, things of this nature here. Okay? So we'll